some water now. So people at home, we were using the Van de Graaff here to, this rubber belt really likes electrons. It tends to accept electrons, and the aluminum ball here tends to give up its electrons. And this belt spins around and is connected to this little tape dispenser looking teeth. And as you can see, those teeth aren't even really touching that belt. So, yeah, I guess you can see it. But the electrons go there anyway. The belt wants them so bad. So if you put your hand on this thing, then you can shock people. And we were attracting the water molecules, so it was stealing all our electrons, and we were becoming positive, so we were attracting the negative side of the water molecules, and that's why this is up here. Anyway, so we're quantifying that attractive force today. It doesn't have to be an attractive force. Like this question has 2 electrons, which each have this charge. Capital C for coulombs is the unit for charge. Charles Coulomb, French guy, studied charge. They're both negative, so they're going to repel. So if the 2 charges are negative, the force will be a repellent force. If the 2 charges are opposite, this force will be an attractive force. But anyway, our formula today is electrostatic force is K is a constant. When they were figuring out this electrostatic force stuff, they're like, well, this formula doesn't work unless I put this exact number right here, and that's this number up here. So every time you use this formula, K is equal to 8.99 times 10 to the 9. And I really recommend you use the shortcut you figured out in the check-in to use your scientific notation function in your calculator. So you say 8.99 E9 or whatever you got. That's the capital E, not the lowercase e. Some iPhones or other calculators probably, after you put it in, it might say lowercase e, but as long as you know you pressed capital E, then that's fine. Not the alphabet capital E, but the one that says, it's usually, it says capital EE, but all that's in the check-in. Anyway, the rest of this formula, you got the 2 charges, Q1 and Q2. Q is charge, and these charges are measured in coulombs. That's what this is, that's its charge. And it's asking, oh, here we go. The rest of the formula there is, this is how far apart they are. Sometimes this is like a radius, because like if I'm attracted to this water molecule over here, I would be attracted to it the same if I'm on the other side over here. So this is really a radius. Sometimes they use R instead of D there, but it really doesn't matter. It's how far you are from the object. And that's in meters. So let's do this question then. It says that the force between those 2 electrons were 100 newtons, or 1,000, sorry. I keep writing 100 with this also. Force is 1,000 newtons. Now you got to be careful reading this. Like y'all's first question on y'all's thing today says, 2 scholars, it probably says students, 2 scholars each had a candy wrapper and gave it a charge of so-and-so, so-and-so. It only gives you the number for that charge. I think it's 0.0001 or something. It only gives you that number once. So you look at it and you're like, there's only 1 charge. But if you read it, there's 2 students and they each had a candy wrapper. So there's 2 candy wrappers, they each have that charge. Q1 is that charge and Q2 is also that charge. It's the same here though. So there's 2 electrons and they each have that negative 1.6 times 10 to the negative 19 coulombs charge. So there's my 1 electron, and here's my other electron. What kind of 6 is this? There. And it's asking how far apart they'd be, so we're solving for the distance. Alright. Y'all's questions on your assignment all are just asking for force, so you're just going to do this times this times this, and then divided by this. If you don't use that, if you don't use that shortcut for scientific notation that you figured out in the check-in, you're going to have to use lots of parentheses here. So you would have to say K times Q1 times Q2, because otherwise since all these things are 8.99 times 10 to the 9 and 1.6 times 10 to the negative 19, when you multiply them, it would say, okay, 8.99 times 10 to the 9 is a number, and then that number times 1.6 is another number, and then that number times 10 to the negative 19 is another number, and it's going to mess you up that way. These numbers have to be together. But if you use that little e shortcut, like you can say 8.99e9 times negative 1.6e19, negative 19, without using parentheses, because the e is there, and the e makes it one number, and the calculator knows. But it doesn't know if you just say times 10 to the. Anyway, let's figure this one out. I've got 1,000 newtons of force. K is always that number.
Is always like
Every time you use this formula, that's why it's, I think probably like the German word for constant starts with a K or something like that, and there's probably a German math guy that was the first guy to use a constant, and that's why it starts with a K. But anytime there's a K like that, it usually means constant. Like if y'all did your rates in chemistry, did y'all do the rates? You got the K for rates. Oh, but I don't know if that's a probably not a great example. So we'll stick to physics. Anytime you see a K, it's a constant, and you can put that right there, only with this formula. There might be a different constant for other formulas. So Q1, 1.6 times 10 to the negative 19, and Q2 is the same thing, because we got 2 electrons, and we're figuring out how much they're repelled from each other. Since they got both negative charge, they're repelled. Because as like charges repel, opposites attract. And we're looking for how far apart they'll be, so we're looking for the distance. Now if you remember, whenever you have something in the denominator like that, you've got to get it out of there. It makes it real difficult if you leave it down there. And this is hard enough as it is. It'll type in all this stuff. So it's divided by d squared. I'll multiply by d squared on both sides. And those cancel. And so I have 1,000 d squared now equals, and I have a number here. No, I'm gonna remember what it is. Hold on. Dang. Okay, hold on. 8.99. My calculator uses an E right there. Let's see if you can see it. Can you see my calculator? See the little E? That's a button above the 7 that has an E above it. That's the little EE that I use. And when I press it, it only gives me one E, and I don't know why. It says 2 E's on the calculator and gives you 1 E in the thing. But as long as I'm pressing capital E. The wrong E to press, let's see, where is that other E? Come here. Well, I can't find it. Ah, no, here it is. See this little yellow E? That's the wrong E. Don't press the lowercase e. You want the capital E right there. So I've got 8.99 E9. That E means times 10 to the. So I don't have to say the times on the calculator. I don't have to say the 10 on the calculator. And I don't have to say the to the. Where's the to the? This thing. I don't have to say times 10 times or 10 or to the. Because E means times 10 to the. So I say 8.99 E9 times a negative 1.6 times 10 to the negative 19. So I'm saying E in my calculator, negative 19. And then times negative 1.6 times 10 to the negative 19. Negative 1.6. This calculator is difficult to press the buttons on. And so I get 2.3 times 10 to the negative 28 now. And that's all these multiplied, makes 2.3 times 10 to the negative 28. I'm solving for d squared, so I'll divide both sides by d squared. Wait, no, I'm doing the wrong thing. I'll divide both sides by 1,000 because I want to get d squared by itself. There, now it says d squared equals. And when I divide this by 1,000, that'll make it 1,000 times smaller. So it'll be the same number, but instead of negative 28, it'll be negative 31 if I can press the buttons. Yeah. 2.3 times 10 to the negative 31. That's d squared. I'm not done yet. I have to take its square root. Square root of answer equals 4.8 times 10 to the negative 16. That's a distance, so it's in meters. So we're talking about electrons here. They're probably in some kind of atom, so that's why the number is so small. They're that close to each other. It's probably kind of big as far as atoms go. That's probably a large distance. And there you go. Please try out this assignment, the Coulomb's law assignment. And because we did all this Van de Graaff messing around, we might need to finish it tomorrow. And people at home, make sure you're not spending more time than one class period on this stuff. Approximately the equivalent of one class period.